today we want to talk about matrices. And matrices are pretty much when you see a box like this with a whole bunch of numbers in it. And it's a way of sorting out information. So each number actually represents some sort of data that we've collected. For example, let's take box A, or this matrix, and this would be considered a 4x3 matrix. And that's because we've got 4 pieces of information going down and 3 pieces across. So if this was just a 3x3 matrix, then we would just have 1 and 2 and 3 going down and 1 and 2 and 3 going across. So we wouldn't have this last column. So as I said, each one of these numbers represents something. For example, this could be, let's say this was like this represented different subjects such as English, maths, science, and social studies. And going down were the number of students that attended in those classes on Monday, Tuesday, and Wednesday. So we have this piece of information which we've labeled as A, and we want to multiply it by the second matrix, which is labeled as B. But this matrix looks a little different, so it's got less numbers. Can you think of what we would label this matrix? So here we've labeled this matrix as 4 times 3. What would this one be? I'll give you a couple of seconds to think about it. And write it down, just so you can check. Okay, as we said, we want to look at how many numbers are going down and how many numbers are across. So going down, we have 1, 2, and 3. So this, we would write it as 3 times, and then going across, we don't have any numbers except for 1. So it's only 1 row and 1 column. So it's going to be 3 times 1. And that's the matrix. And in the IB problem, you might see what is A times B equal to. And what that's really going to ask you to do is to multiply the 4 times 3 matrix by the 3 times 1 matrix. Now the general rule for when you do this is that, let me just get my pen. When you want to multiply 2 matrices with each other, we're going to say 4, let's say that equals M times N. And we want to multiply that by 3, which in this case is N times P. So this would be, the M times N would be 4 times 3, and the N times P would be the representation of 3 times 1. And the general rules, when we have something like this, we just cross out the 2 ends. So we would be left with M times P. So we'd be left with M times P. So in this case, our M would be the 4, our N is 3, our N again is 3, and our P is 1. So we're going to cross out the N's, which are the 3's. We're not going to include that in our answer. So when you have A times B, in this case, we're going to end up with these 2 being crossed out, and we're going to have 4 times 1. Here's our 4, and here's our 1. And that's the matrix that you're going to have. So you're going to have something that looks like 1, 2, 3, 4. So it's only 1 across and 4 down. Let's take a look at this example. So here we have matrix A times matrix B. And matrix A is a 4 by 3 matrix, while matrix B is a 3 by 1 matrix. And we want to find out what A times B is equal to. And so So that would be matrix labelled AB, which really means A times B. The way to do this is we need to multiply each column by one of these numbers. So for one column that has 1, 4, 2 and 0, we're going to multiply that by 3. For the second column here, we're going to multiply that by 1. And the third column, we're going to multiply all of these numbers by 0. So as you can see here, I had the original numbers written down, and we multiplied this chunk by 3, this chunk by 1, and this chunk by 0. And you have to add across. This is going to leave us with a 4 by 1 matrix. 4 down and 1 across. And obviously all I did here was 3 times 1 is equal to 3, plus 0 is equal to 3. 4 times 3 is equal to 12, plus 3 is equal to 15. That's what I wrote here. 2 times 3 is 6, plus 0 is 6. 0 times 3 is 0, 0 times 1 is 0, and 0 times 0 is 0. So we're left with 0. So that's our final answer for A times B. So if we had a matrix that was A was equal to 4 times 3 and B was equal to 3 times 1, it's important to note that matrices are not, they have something a bit special about them. For example, you can actually do A times B, but you can't do B times A. Let's have a closer look. So if we had A and B, and A was equal to 4 times 3 and B was equal to 3 times 1, we would write it out like this. What we notice here is that the two middle numbers, which are 3 and 3, are equal. They're the same number. If we flip these two brackets around so that it's 3 times 1, then times 4 times 3. So this one was A and B, and now it's B and A. What we notice is that the middle numbers are actually no longer the same. They are not equal anymore. And that means, this is really important because this cannot work. You cannot multiply these by each other. So this means that A times B is not equal to B times A. So the order of the matrix, or the matrices, actually matters because the matrices are not commutative. So that means, what commutative means is that A times B is not equal to B times A. So unlike when we would usually have, for example, if we looked right over here, it says 4 times 3. 4 times 3 is equal to 12, and 3 times 4, if we switch them around, is also equal to 12. These are commutative because they both equal the same number.